Example number 2 for the chain rule. Again, you'll see that I'm using the trig functions. I think it's so much easier to explain the chain rule with the trig function before getting into other expressions. When I look at this problem, it says y equals sine to the fifth, x to the fourth. Now recall, this is the same as saying sine x to the fourth quantity raised to the fifth. And you'll see in the next line it's actually what I wrote. And so before I even do any derivative, I want to write this in the power form so I can first start off by using the power rule. And so as I use my power rule, I'll say y prime is equal to 5 times sine the angle, x to the fourth, raised to the fourth. You see I knocked that power down by 1, and I put that exponent in the front. Then I have to come back, and the chain rule states that what's in parentheses has to have a derivative. So the derivative of sine x to the fourth would be cosine x to the fourth. And then last, I have to go to that innermost set of parentheses, this x to the fourth, and that will create another link in the chain, and we'll call that 4x cubed. So again, I started with my power rule, 5 sine x to the fourth, knocked it down by a power. I looked at this set of parentheses, took the derivative of the trig function, gave me cosine x to the fourth, and then I had to do the derivative of the angle. And so it created two links here, 4x cubed. And then my last step, because I had this 4x cubed here, I don't usually like to have expressions lingering after trig functions, so I brought that to the front. 4x cubed times 5 gave me 20x cubed. Sine to the fourth, x to the fourth. See, I went back to their traditional notation. And then our cosine x to the fourth. And that's our final example, or second example, for the chain rule.